Hi, this is Mrs. Davis. This is AP Pre-Calculus. We are in Unit 2A going over the review packet for the test. We're on number 15. Okay. First, it says we're talking about transformations. It wants us to name the transformations when we're doing times 9. And so we can rewrite this as 9 times 9 to the x, which is 9 to the x plus 1. So we have g of x is f of x translated 1 to the left. All right, let's look at what's happening here. We have 16. So we have 2 to the x, and then 2 to the x over 16. So we have 2 to the x times 2 to the negative 4. So that is 2 to the x minus 4. So that would be g of x is f of x translated 4 to the right this time. Okay, now 7x and then g of x is f of x to the negative 3. Okay, so this is like power to power now. So we would have 7x to the negative 3, which is 7 to the negative 3x. So two things going on here. G of x would be f of x, and first it's reflected over the y-axis and then horizontally dilated by a factor of 1/3. All right, looking at this one, we have negative 7 to the x times 7 to the negative 2. So this is negative 7 to the x minus 2. So several things going along here. We have g of x is f of x. First, it would be translated right 2, and then reflected. This is the right 2 and reflected this time over the x-axis. Okay, so there was some transformations. Now let's look at what's going on with number 19. They just want us to find these values. So h of 2, we put 2 in for x, equals 6 times 4 to the 2/3. Now 4 to the 2/3 is not going to come out to be a whole number, so this would be 6 times the cube root of 16. We can write it like that. So h of 2 is that. 9 times, we're going to put negative 1 here, so h of negative 1 would be 9 times 2 to the negative 1/5, which is equal to 9 over the 5th root of 2. Can't do anything else with that. All right, let's see, 21. Write the equation for this exponential function. Okay, so this is one that's been translated, so it's going to be a common ratio, but it could be a certain number away. So, I always start with 1, 2, 3, 4. So if this was 2, so it would be 2 to the 0 plus 1 gives you, 2 to the 0 plus 2. This would be 2 to the 1 plus 4, so that's not got the same plus, so that's k wouldn't be the same here, so it's not 2. Let's try 3. This would be 3 to the 0 plus 2, and this would be 3 to the 1 plus 3, again, not working. So let's go to 4. This would be 4 to the 0 plus 2, and then this would be 4 to the 1 plus 2. Aha, 4 to the 2 plus 2, that's 16 plus 2 is 18. 4 to the 3 is 64 plus 2 is 66. So we have that R is equal to 4, K is equal to 2, and now we have to find A. So we can write, so far we have f of x is A times 4 to the x plus 2, and now take one of those numbers, 0, 3, and put it in there. We get 3 to find A equals A times 4 to the 0 plus 2. So 3 is A plus 2, so A is 1. So actually A is 1, so f of x is just 4 to the x plus 2. Okay, moving on to 22. It's like a mini free response, but this time it's a regression model, so you're going to need your calculator. So you're going to first use regression, so that would be stat edit, so put these in L1 and L2, put those into your calculator. So go ahead and do that and then come back, and then it says go ahead and round to 3 decimals, but store the equation in your calculator. So if you go to regression, exponential regression, which is 0, stat calc 0, you should get f of t is equal to 0.078, rounding, 1.288 to the t. So according to the model, how much will the catfish weigh after 5 weeks? So you would write f of 5 is equal to 0.078 times 1.288 to the t. Now, if you kept your y1 in there like I showed you, then you can do y1 of, sorry, this would be 5, y1 of 5. So that's equal to 0.275 pounds. How about after 7 weeks? So f of 7 is 0.078 times 1.288 to the 7th, which is 0.457 pounds. Again, you would do y1 of 7. If the model continues past 9 weeks, when will the catfish weigh 1 pound? So now you're going to say 1 equals 0.078 times 1.288 to the t. And if you put y1 equal to 1 and y2 equal to 0.078, 1.288 to the t, and then graph those and look for the intersection. So if you have that, you should get that t is equal to 0.087. Nope, that's the next thing. I'm sorry. Read my thing wrong. T should be 10 something. T equals 10. That was my next thing. T was 10.098 weeks. How's that sound? A little better? Use the model from part A to find the error at t equals 8. So remember, error is EPA. Error is equal to predicted minus actual. So again, error is predicted minus actual. So that would be, we need y1 of 8, and y1 of 8 is, or it's f of 8 if we're doing it for the function, but on your calculator you'll put y1 of 8 in there, and you should get 0.501. No, that, oops, sorry. I see what I was doing now. F of 8 came out to be, on my calculator, 0.588048. So then you take that 0.501, the actual from the table, and you get 0.087. All right, so that would be the error And then it says, is the value predicted an overestimate or underestimate? So the error is greater than 0. So that means if we're like sketching this out, if I have my function, my predicted, and it's predicted minus actual is positive, that means the predicted has to be over the actual. So it would be an overestimate. So we'll say because error equals 0.087, which is greater than 0, the value wants the value predicted, right? So we'll say that back. The value predicted is an overestimate. All right, so there is the second video of this set.